All right, 2.2. Function is it's a function if what about a line? If hits at most one point. That's a function is when the graph looks such that a vertical line hits only one place. If it goes two places, then for an input there'd be two outputs, and that's non-functional. So if a vertical line hits the curve at only one point, vertical is C-A-L, not L-E. Now it says figure out A if this goes through minus 1, 2. That means x is minus 1 and y, this side, is 2. So 2 equals a times negative 1 squared plus 4. So negative 1 squared is 1 times a. So a plus 4 is 2. Then a must be, subtract 4, and you get negative 2 equals 1a, or a. Is it true or false? The y-intercept of a function let's see, I got to look at that again. My notes are not clear enough here. For me, let's see. 8. What was it asking? True or false? The y-intercept of a graph of a function f of x, whose domain is, so what is f if we're trying to find the y-intercept? It's the y value when x is 0. So you make x be 0 to find the y value, or the y-intercept. If x and y is the coordinate x, y in the xy plane that satisfy equation, and if you do all of those, you get what's called the graph of the equation. You keep finding x's and y's that work in the equation. For instance, if I had x plus y equals 1, then 1, 0, 1 and 0 works, and that's there. 0 and 1 works. 2 and minus 1 work, and minus 1 and plus 2 work for x and y. And if I keep doing all the possibilities, I get this line. And so that's the graph of this relation or equation. If y equals f of x, can have, if it's a function, it can have more than one, not y-intercept, because then it wouldn't pass the vertical line test. It can have more than one x-intercept. Okay, for 15, it says, is this a function? Well, it passes the vertical line test because it only hits it once every place. So the domain of this one, it looks like it goes from minus pi to pi. In the x's, that's what the domain is. The range goes from minus 1 is the low to the high is plus 1. Does it have any intercepts? It looks like intercepts are points. So it's when x is negative pi over 2, halfway between 0 and negative pi. It's 0, and that's an x-intercept. And there's another x-intercept over here, and that looks like it's pi over 2, 0. And there's a y-intercept, and that happens to be 0 in the x and 1 in the y. Intercepts are points, so you should do them with parentheses. And does this have x-axis symmetry? Is it the same? Is there's a matching graph below as above? Would it fold together and match? Nope. Does it have y-axis intercept? Yep, that folds over and matches up, so yes. Does it have origin symmetry? So over here, there's a point across the origin. Over here, there's not a point across from the origin, so no. Okay. Now, if this is a function, we're supposed to answer the same kinds of questions, but this is not a function. So That's all we have to say on this one. We don't talk about the domain and range because it's not a function. We could talk about the intercepts. The x-intercept and y-intercept are 0, 0, but it said if it's not a function, don't worry about it. Does it have symmetry? Yes, it has symmetry over the x-axis, but not y or origin. But it said it's not a function, so don't worry about it. And this one has x-axis symmetry, y-axis symmetry, origin symmetry. For every point, there's something across from it. Has all the symmetries. Has x-intercepts of 2, 0 and minus 2, 0, y-intercepts of 0, 2 and 0, minus 2. But it's not a function. And the domain would be from minus 2 to 2, and the range would be from minus 2 to 2, but it's not a function, so we don't have to do any of that. Now, 31 says find f plus g of 2. So f of 2 is 2. G of 2 is 1. So f plus g at 2 is 3. F plus g at 4. 4, f is 1. At 4, g is minus, let's see, that's minus 1, 2, 3. So this is minus 2. F minus g at 6. F is 0 at 6, and g is 1. 0 minus 1 is negative 1. G minus f at 6, that would be 1 minus 0, which is 1. F times g at 2. That would be f was 2, g was 1. Multiply them, we get 2. F divided by g at 4. F is 1 at 4. And g is minus 3. Down here at 4, negative 3. All right, this is the weight. This is the basketball, the height of the ball. If you shoot from the foul line, so you got the basketball court, and here's the foul line, and up here's the basket, and the hoop, and the net, and all that kind of stuff, and you're shooting, and the ball is trying to make it into there. This is 15 feet. The basket hoop is 10 feet. And it says, figure out the height at 8 feet. So we put 8 in there, and it said the velocity is 28. But I'm going to do it the simple way. Turn on my calculator, push y equals, and I'm going to type in this equation. Negative 44x squared divided by 28 squared plus x plus 6. And then I'm going to go to my second table set, and I'm going to put it on ask. And then I'm going to go to the table, which is, table sets there, table is there, so second there. And I get a table, and when I'm in ask, I can put in numbers. They want me to put in 8. So I'll put in 8, and it says the height is 10.4 feet. It says, what's the height at 12 feet? So I type in 12, and it says it's 9.9 feet. So at 8 feet, if this is 15, 8 feet, it's at 10.4. At 12, it's 9.9. So it's on its way down. Now it says graph it. Well, if I have it in the equation, I can go window. I want to look from zero's the here. So I can start at -1 foot and go clear past the basket, which would be at +15. So I'll go to 16 feet. And then Y, zero's the floor height. And the maximum height, if that's 10, we probably won't go over 15 feet. So I'll put that. Now I'll push graph. And there it goes. So it starts at 6 foot, not here, because they said start at a height of 6. Why? Well, probably the guy is 6 foot. 6 foot, and it goes up and down. Okay. And it says the hoop is at 10 feet, 15 feet away, and we'll make a basket. So if we go up here, second count, no, just trace, and we're at 7.5 feet. If I keep going over to 10 feet and see how high it is, well, near 10 feet, it's at 10.38 feet, and it's coming down. Did I put in something wrong? 44, negative 44 x squared over 28 squared plus x plus 6. Did I get that written right? Or was there a minus in there? Nope, that's right. So it looks like, oh no, we got to get over to 15 feet. We're only at 10 feet. We got to get over here to 15. Okay, now you can see that at 12 feet, it's already come down too much. It's below 10 feet, and at 15 feet, it is at 8 feet. It's going to come down below the basket. Or we could have gone to table and said, well, let's see how high it is at 15 feet. Too low, missed. Okay? Next one. This one's about the weight as you go up Pikes Peak. And it said, this is the formula if M is the mass or the weight of the person. And they said, let's talk about a 120-pound person. So I'm going to put the formula in, clear this one out, and put in M as 120, parenthesis. The numerator is 4,000. It's not complicated, so I don't need to put it in separate parentheses. Divided by, and now we got a complicated denominator, so I need to go parenthesis 4,000 plus x I'll use for the h. Close the denominator, close the fraction, and square it. Okay. And now let's go. We're still on table set, so we can go to table set. It's still on ask, so I can go to table, and I can delete these. Let's see. I should be able to delete them. Delete. There we go. Delete, delete. We're supposed to find out at Pikes Peak. Now, H, this is what people miss on this one. It says H is miles high, not feet high. Pikes Peak's 14,110. So we have to put in feet for H, or for the X. So we need to put in 14,110 divided by 5,280 feet in a mile. So we're only 2.67 miles high, and the weight would be 119.84 pounds. It says graph it. Okay, so what would the window have to be? Well, the height we're going to be, we could be anywhere from -1 mile up to probably not more than 10 miles high. And the minimum, well, the maximum weight's 120. The minimum doesn't look like it's going down very much. Let's go from 100 to 120 pounds. Graph. Didn't drop very fast, did it? And it says start the table set, do table set, start at 0 and make it jump by 0.5. And so we want this on auto now. So I press enter to make it auto. Go to the table and we can see it's losing weight as we go every half mile, mile and a half. And it says, so we did that. And then it says 1 would weigh 19.95. Looks like about 1 mile high. And is this reasonable? Yeah, you don't lose that much weight. Go a mile high, you only down by 0.05 of a pound, half of a tenth of a pound. Okay. Now, those of you who use this for H and not this divided by 5,280, you got unreasonable answers. And now, the final problem. It said, here's a graph of somebody's velocity in miles per hour as time in seconds, I think, or minutes. Okay, so one way to go on the fastest, well, the highest place. So that was from 7 to 7.4. This would be done at intervals, so 7 to 7.4. Now the rest of them I'll just tell you, so I don't have to write so much here. B, when was the velocity 0? At 0 and between 4.2 to 6 and at 9.1. What was the speed doing between 0 and 2? It was increasing to 30, from 0 to 30. What was happening at 4.2 to 6? The speed was 0, so that must mean it stopped. Whoops, get this up where you can see it. Move that out of the way there. What's happening between 7 and 7.4? Going at a steady speed of 50. When is the speed constant? Well, it's constant from 2 to 4, speed of 30. This was 30, not 36. It was constant from 4.2 to 6, stopped, constant speed. It was constant from 7 to 7.4, the speed was 50. And it was constant from 7.6 to 8, at 38. So there's constant 1, 2, 3, 4 intervals for the F. Okay? And that's that section.